Okay, so in this video, we will be going over the uses of influence lines, and we'll be going over two problems that deal with point loads. Okay, so problem 1 reads, for the beam shown, use the influence line to compute the reaction at B, the shear at C, and the moment at C. We will start off by doing the reaction at B. So we just first have to draw the beam. We can label this part A, part B, part C, and part D. So we now have to draw the influence line for the reaction at B. So to do that, we know that we go at point B and we draw the line 1 unit up, which the influence line will look something like this, with this being 1 unit length. We will now need to compute the slope of this line. So we know that this length is equal to 10 plus 10 plus 5, which is equal to 25 feet. And that means this has a slope of 1 over 25. So then now we can go ahead and draw on the diagram where the point load is. So the point load will be here between A and C. So now we can calculate the reaction at B. So for that, we will take the distance from A to the point load, which will be 10 feet, over the distance from A to B, which is this entire length, which is 25 feet. And we will multiply it by the point load, which is equal to 4 kips, which means that the reaction at B is equal to 4 kips. For this part, how we got that part is that basically you're multiplying the distance from the A to the point load and multiplying that by the slope, which was 1 over 25. So our answer, as mentioned before, will be 4 kips. So now we'll minimize this so that we can move on to calculating the shear at C. For the shear at C, we will start off by doing the same thing, which is drawing the beam and labeling it as part A, part B, part D, and part C. So now we will draw the influence line for the shear at C. So we know there's going to be a total of 1 unit, but we still don't know the length of each. And the influence line will go here, as well as this. So now we will do a sine calculation in order to calculate what these points are. So we will do for the 5 feet. We know that the distance from C to B is 5 feet over 25 feet, which will equal to 0.2, which means that this is 0.2. And then we will do the distance from A to C, which is 20 feet over 25 feet, which will give us 0.8, which means that this will be 0.8. So now we will draw where the point load is, which is here. This is where the 10 kips are. So now we have to calculate the slope of this line, which will be negative 0.8 over 20. So now we can calculate the shear at C by multiplying by the slope, which is negative 0.8 over 20, by the distance from A to load of the 10K, which is 10 feet, times the load, which is 10 kips, which will equal to negative 4. So the shear at C is equal to negative 4 kips. And that is our answer for the shear at C. And we'll now minimize this so we can work on the moment at C. For the moment at C, we will start off by doing the same thing, which is drawing the beam and labeling the parts, which is A, D, B, and C. We will then draw the influence line for the moment at C. We will do this like this. And we know that when we draw the influence line for the moment, this is 1 unit, and as well as this is 1 unit. In order to solve for this here, this distance here, we will use angles and we will use the parallel lines. So we know that this angle, we will call this angle angle A, because it's the same as this angle, and we will call this angle B, which is the same as this angle. We will do a side calculation, which is that angle A plus angle B is equal to 1, and that angle A is equal to tan A, which is equal to, we'll call this B, and then we know we'll put that tan of A is equal to EC over 20, and that angle B is equal to EC over 5. And if we add angle A to angle B, we get, that would be 5EC plus 20EC over 20 times 5 is equal to 1. And we solve for EC, we get the EC is equal to 4, so we know that this will equal to 4. Now we can minimize it. And now we will draw where the point load is, which we know will be here. This will be where the 10 kips is. So now we know that we have to find this slope, which we know that the slope will be 4 over 20. So now we can solve for the moment at C by multiplying 10 kips, which is the point load, times 10 feet, which is the distance from A to the loading, to a load of 10K, times the slope, which is 4 over 20, and we get 20 kips per foot. So that the moment at C is equal to 20 kips per foot. And that will be our answer for part C. So that is problem 1 solved. You can also go ahead and check your work for the reaction at B, the shear at C, and the moment at C by doing what you would normally do without using the influence lines. For example, this will be the work for calculating the reaction at B. We get the same thing, which is 4 kips. Now we can go ahead and move on to problem 2. Problem 2 reads, for the beam shown, use an influence line to compute the shear at B and moment at B. So we will start off by computing the shear at B. And we will start off the same way we started off the first problem, which is drawing the beam. And we'll label this A, C, and B. We will then draw the influence line for the shear at B. We know that this will have to be a total of 1 unit. So then we finish drawing the influence line, which will look something like this. This drawing does not look, it's not going to be proportional, but it doesn't matter. So we know that since all of them are the same length, we know that this will be 0.5, and this will be 0.5, as well as this and this. We will now go ahead and draw where the point loads will be. So we can see that the first point load, this one here, is a distance of 2 meters from the edge. So we know that it will be here, which means that this distance will be 8 meters. And then we will draw the second point load, which is here. And we can tell by using these distances that this will be in the middle of this triangle. We will then draw the third point load, which is here, which we know will also be in the middle of this triangle. We will then identify that the slope at this line is equal to 0.5 over 10, and as well as this line, the slope will also be 0.5 over 10. We have to take note that this part will be positive and this part will be negative. So we have to take that into account when calculating the shear beam. To calculate the shear beam, we will do the 10 kilonewtons, which is from the point load, times the slope, which is 0.5 over 10, times the distance from the load 10K to the nearest support, which is will be the 8 meters that we mentioned before. Then we will add the point load, which of 30 kilonewtons, times the slope, which is 0.5 over 10, times the 5 meters, which is this distance of 5 meters. We will then subtract the point load of 20 kilonewtons, since it's in the bottom, as we mentioned before, times the slope, which is 0.5 over 10, times the distance, which is 5 meters. We will get 4 plus 7.5 minus 5 is equal to 6.5 kilonewtons. which means that the shear at B is equal to 6.5 kilonewtons. And that is our answer for part 1 of this problem. We will now minimize it so we can move on to finding the moment at B. We will then move on to calculating the moment at B. We will start off once again by drawing the beam. We will label this A, C, and B. We will then draw the influence line, which will look something like this. And once again, the drawings are not going to look proportional. We will do the same thing as we did in problem 1 to calculate this distance here. So this will be angle A, and this will be angle C. We will do angle A, and this will be angle C. We will do a calculation to calculate that, which will be angle A is equal to tan A, which is what we will call this E. We'll call this E, which will be EB over 10, and angle C will be EB over 10. We add these and set them equal to 1. And we get that EB is equal to 5. So from this, we know that this is also 5, and this is also 5. So then we will go ahead and draw where the point loads are, which we will draw here. And once again, this is 8 meters. And then we will draw this here, which again, we know that this is 5 meters. And the last point load is here, which is 5 meters. And once again, we have to notice that this is positive and this is negative. So when we calculate the moment at B, starting with the first load here, we know that it's negative, so we will do negative 10 kilonewtons. And then we also have to, then we have to do the slope. The slope at this line is 5 over 10, and the same slope is over here, which is 5 over 10. So then we will multiply it by the 5 over 10, which is the slope, times the 8 meters that we mentioned. And then we will do the second one. Now we add this one because this one is up, which is positive. So we will do the 30 kilonewtons times the slope, which is 5 over 10, times the distance, which we mentioned was 5 meters. And once again, this last point load is below it, so it will be minus 20 kilonewtons times the slope, which is 5 over 10, times the distance, which is 5 meters. We get negative 40 plus 75 minus 50 is equal to negative 15 kilonewtons per meter. So we get that the moment at B is equal to negative 15 kilonewtons per meter. And that is our answer for part B of this problem. And that is the whole problem completed. So when calculating these type of problems, you go ahead and you draw the influence lines and find the slopes, and then to calculate the shear moment or reaction, you do the distance from load to the nearest support times the slope of the line times the point load. And you get the reaction, the shear, or the moment. That is the basic formula that you're going to use to calculate these type of problems that include point loads. So that will be all for this video, and thank you.